Okay, so next section. You might notice that the previous section was 2.5, and now we're kind of going back to 2.4. It's complex numbers. That's because this section very much builds into what we just saw. In fact, it seems almost disconnected, but now that we know how to solve quadratics, we can say, okay, well, there's a special type of quadratics that needs a concept like complex numbers, and hence complex numbers are important. So here's an equation that in the last section we would have been able to solve. At least seems like we would be able to solve. First step would be we would subtract 1 from both sides, and then we would take the square root of both sides. But that creates an issue. We can't really take the square root of a negative number. There is no number in the real numbers that if you multiply it by itself, you'll get back a -1, or a negative number, any negative number for that matter. So we introduce this idea of imaginary numbers. And that allows us to solve this equation. So an imaginary number is a number whose square root is -1. So if you see I, that just means it's the square root of -1. And for that matter, if you square I, then -1 square root times the -1 square root gets rid of the square root, and you have -1. And really that's pretty much the idea of this entire section. Is it's going to build on this. Do we understand what I is, where it comes from, and do we understand what I squared is? So let's kind of dive into that. Now here's a question that we wouldn't know the answer to previous to imaginary numbers. We would have to stop and say there's no real solution. Well, what we can do with this idea of imaginary numbers is we can kind of split the -49 into two parts. And say, okay, I don't know what the square root of -49 is, but if I break it up, I know what the square root of -1 is now, and I also know what the square root of 49 is. Square root of 49 is 7, and square root of -1 is I. And then just as kind of notation, we typically write the number and then I, just like we do with variables. You usually put the number in front of the other. So I times 7 is technically correct, but the notation that you'll see most often would be 7i. Same type of idea with square root of -7. I'm going to break it up into two pieces. Now in this case, I don't really know what the square root of 7 is. And yes, you're allowed calculators in this course. So you might be able to find a decimal approximation, but I'd prefer you didn't. So we're just going to leave the square root of 7 alone and just say, well, now I know the square root of -1 is I. That's my answer, I root 7. Let's do one more example. So in this case, I have a negative square root of -4, exact same concept. I'm going to split up my square root into two separate parts, but we have to be careful. I'm not going to put that negative and have any double negatives cancel out or anything like that. I can't move a square root or a negative under a square root. I can't move a negative inside a square root outside of it. So I just have to leave that negative where it is. I know the square root of -1 is I. I know the square root of 4 is 2, so I get my final answer of -2i. Now multiplying and dividing. Normally, if we have positive numbers only, if I'm multiplying with square roots, I can just multiply whatever's under the square root and then take the square root. I can't do that with imaginary numbers, so I have to go back to that first step that we saw on the previous slide. I'm going to split up my negative square root of 5. I'm going to split up my square root of -6. Well, we could write it out again and again and again, but we know square root of -1 is just I. So my first term is going to become I root 5. My second term is going to be I root 6. And now I can combine like terms. I can multiply whatever is under the square root to get root 30. And I can multiply the i's. That will get me I squared, square root of 30. But we talked about at the very first slide, I squared is -1, and so we don't really want to deal with imaginary numbers if we can avoid them. So we know I squared is -1, let's go ahead and say that, and now we have a real answer. And notice how this is different if you would have just multiplied that -5 times -6. You wouldn't have gotten a negative square root of 30. So make sure you're doing this process if you're multiplying or dividing, or adding and subtracting for that matter. Now for this question, I don't have to break up the second square root because it's -1 already. So the second square root is going to be I. And if I split up that first square root, I'm going to have I root 9. So I'm left with root 9I times I. Well, the square root of 9 is 3. And I squared is -1. So I get -3. With division. same concept. Bottom, I don't have to do anything. I don't have to do any simplification. There's no square root. On the top, I have to factor out that -1. So I get -1 times the square root of 27 over the square root of 3. Now that I have a positive square root on top and a positive square root on bottom, I can go ahead and divide those. That's perfectly fine. I don't have to do any more work. So 27 divided by 3 will get me 9. And I know square root of 9 is 3. I know the square root of -1 is I. So I'm left with 3i. Now, complex numbers. Complex numbers is kind of encapsulates both real numbers and imaginary numbers. And so sometimes you could have a situation where you have 3 plus some sort of imaginary number, and that gives us this complex number. So by definition, a complex number is if you have a real number a plus a real number times an imaginary number, so b times I. And the cool thing about complex numbers is they follow all of the operations that we've seen: multiplication, division, subtraction, squaring. And anytime you do a complex number, you will still get a complex number out. So that's kind of why we talked about I squared being changed into something. There is no I squared in a complex number, but we know now that that's a real number. So we're going to always be able to simplify back to some complex number. The easiest form to deal with complex numbers is adding or subtracting. Because at this point, it honestly doesn't really matter what I is. We just treat it as though it's a variable. And so I'm just going to combine like terms. Well, 3 plus -4 gets me -1. -5i plus I gets me -4i. Ooh, I kind of skipped ahead a step. And then I'm just going to get -1 minus 4i. I guess what I should have explicitly said is that if there's a plus in the middle, you can just go ahead and drop the parentheses and then combine like terms. It's a little bit different if you have a minus in between your two complex numbers. So yeah, 4i is an imaginary number, but 4i is in the group overall of complex numbers. So my two complex numbers that I'm subtracting here are 4i minus 3 minus I. And if I'm subtracting, if I have that subtraction in front of my parentheses, my first step is to distribute the -1 to both things inside the parentheses. So my equation becomes -1 times 3 gets me -3, and -1 times -I gets me positive I. And now I can combine like terms just like I did previously. 4i plus I gets me 5i, and -3 doesn't combine with anything, so I'm just left with -3 plus 5i. While I'm thinking about it, yes, technically the order doesn't super matter. Like if you were taking a test and you wrote 5i minus 3, that works. It's just a good convention to say, okay, I'm always going to have my real number first and